Good evening, everyone. Uh, the O-level A Math paper will be on Wednesday afternoon. It's currently Monday night. We'll go through Methodist Girls A Math Prelim 2022 Paper 1 tonight, and I'll try to get Paper 2 up before Friday because that will be the Paper 2 date. So, all the best to all the students taking it, and let's go through the paper. So, I've had a look at the paper. It doesn't seem too difficult overall. First question is very standard. You have a triangle with this base and this area. Find the perpendicular height. So remember that the formula is half BH, half times base times height. So what I need to do is actually find 12 plus 7 root 3, divide by root 3 plus 2, and then this one times 2. Okay, so we will simplify this. So I will write this as 12 plus 7 root 3. You need to multiply the conjugate cert at the bottom, so you'll write 2 minus root 3. And then at the bottom, you multiply the conjugate certs together, you'll get 2 plus root 3, 2 minus root 3, so you actually just get 1. Okay, we can simplify this a bit. So 2, we can expand this, so we'll get 24 minus 12 root 3 plus 14 root 3 minus 7 times 3, so 21. And this is 3 plus 2 root 3 times 2, so 6 plus 4 root 3. Okay, so therefore A equals to 6, B equals to 4, right? Okay, so that's a good start. Okay, equation of curve is this. Find the range of values of P. Curve lies completely above the x-axis. So completely above the x-axis, take note that this means P is a positive. So we will of course consider the discriminant. So write discriminant greater than 0 lies completely, less than 0, because there will be no solutions to the corresponding quadratic equation. So you will get 16 minus 64 p squared to be less than 0. You can make p squared the subject. P squared will be greater than 1 over 4. Okay, so therefore p less than negative half, which is rejected because the p is positive, or p is greater than half. So p is greater than half will be your answer. Find the value of h for which the line y equals 2x plus h is tangent to this curve. Okay, so for this one we can also consider discriminant. So we'll write the corresponding quadratic equation. So take curve minus line, 2x squared minus 8x plus 5 minus h is 0. Discriminant will be equals to 0. In other words, 64, and then minus 8, 5 minus h is equals to 0. So you can see 5 minus h must be equals to 8. So h is negative 3. Cool. Okay, question 3 is a trigo ratios. Tangent A is 5 over 12, sine B is negative 3 over 5. A and B are in the same quadrant. So if you do your ASTC, you will be able to find that it will be the third quadrant. So calculate the following values. Okay, so tangent A is 5 over 12 and it's the third quadrant. So here's what the graph is going to look like. So if I draw the triangle, so looks like this. Yeah, looks like that. So this is A. So this is the minus 5, and this is the minus 12. And the hypotenuse, right angle triangle, so actually should draw the right angle on that side, on the side where the pole is. So that will be here. Okay, so this one is 13, right? So cosecant negative A. So sine is usually negative, but remember that this is equals to negative 1 over sine A. And what is sine A? Well, sine A will be the opposite over the hypotenuse, the opposite being negative 5. So it is equals to negative of 1 over negative 5 over 13, which is 13 over 5, positive. Sine 2b, okay, how do we find this? So for this one, A and B are in the same quadrant, so 2b will be sine 2, or rather sine b is negative 3 over 5, so what does that look like? So this is b, this is the right angle. Actually, no, this is the right angle. This is 5, this is negative 3, and this is negative 4. Okay, so we can see that cosine b is negative 4 over 5. So therefore, sine 2b, which you can use the double angle formula, 2 sine b cosine b. We know sine b is negative 3 over 5, cosine b is negative 4 over 5, so multiply together will become positive 24 over 25. And finally, tangent A plus B. For this, we'll need to know what is tangent B. We know what is tangent A. Tangent B turns out to be negative 3 over 5 divided by negative 4 over 5, because sine over cosine. So this is positive 3 over 4. So tangent of A plus B is equals to tangent A plus tangent B. So that will be 5 over 12 plus 3 over 4. Then 1 minus the product of tangent A and tangent B. And then you can work out what this is. And you'll find that, oh, that's weird. Oops, that's not what I meant to do. And you'll find that the answer is actually exactly 56 over 33. So it doesn't seem like too nice of an answer, but this is the answer, and you can check for yourself. 4a, solve the following equation. Okay. So we're going to, for this type of indices kind of equation, usually the trick is to use a substitution. So we're going to let u equals to 2 to the power of x in this case and see what happens. So we're going to write 2 to the power of 2x plus 1 as 2 times 2 to the power of 2x minus 17 times 2 to the power of x plus 21 equals to 0. And in fact, I'm going to bring the 2 on the outside so that I get 2 to the power of x squared. So it's the same thing because of the index laws, right? So therefore, I get 2u squared minus 17u plus 21 equals to 0. This is a quadratic equation that can be solved by the normal means. And I believe this is a factorable one. So I believe it's 2u minus 3 and u minus 7 equals to 0. So u equals to 3 over 2 or u equals to 7. Now this means 2 to the power of x is equals to 3 over 2 or 2 to the power of x equals to 7. And you can go ahead and solve this the normal way. So x is ln 3 over 2 divided by ln 2, or x is ln 7 divided by ln 2. And you can evaluate those numbers. I happen to have the answers written down here, so... Oh wait, I don't, sorry. So let's find out what the answers are. So we have 0.585 as one answer, or the other possibility being ln 7 divided by ln 2, which is 2.81. Okay, so these are 3SF, of course. Explain why this equation does not have a solution if p is greater than this thing. Okay, so we're going to consider the equation. We've reduced this equation already. We can see that the corresponding equation is 2u squared minus 17u plus p equals to 0. And for this, we can consider the discriminant. We need the discriminant to be less than 0 for no solution. For this, what's going to happen is 17 squared is 289, has to be oh wait, minus 2 times 4 times p, so 8p. This has to be less than 0, so p in this case is greater than 289 over 8, which is equals to, I think, 36 1 over 8, because 36 times 8 is yeah, it's 288, so yes. Okay, so you can go ahead and explain a little bit. So basically just say uh, for no real roots. Okay, maybe you can explain a little bit. Okay. uh, Exponential word problem. Find initial mass. Okay, I don't really need to go through this. I think this should be easy. 10.2 grams. uh, Sketch the following graph. Okay, so hopefully you guys know how an exponential graph looks like. So this is t and this is m, right? So we're gonna start at 10.2 and it's gonna go downwards. Something, yeah, it's an exponential curve, but it's going downwards, and it's going to approach a certain line, but it will never meet this line. This is a horizontal asymptote of y equals to. What happens as t goes to infinity? Well, this goes to 0, so this is 0.2. Okay, so it will look something like, no, that doesn't look right. The gradient should always be decreasing downwards, but or rather the curve is concave upwards, but it will never touch the asymptote, right? A bit hard to draw with my pen now, but you get the idea. Okay, y equals to, or rather m equals to 10e minus 0.01t plus 0.2. Okay, and this is the origin. Okay, so that's the shape and the asymptote will do. Find the least number of days it takes before the substance is reduced to 5% of its initial mass. Okay, so that will be 5% of initial mass is 5% of initial mass. This is 0.05 times 10.2, right? And this is 0.51. So solve the equation 10e minus 0.01t equals to, or rather plus 0.2 equals 0.51, but you can write this as 0.31 as well. So in other words, minus 0.01t equals to ln of 0.031. Sorry for the sniffing, by the way, I'm not feeling very well. And of course you can solve for t. T is negative 100 ln 0.031, and you can evaluate what this is. You get 347.38 5SF. So we're going to round up to the nearest day. So least number of days will be rounded up to the next one, so 348. Okay, explain why the mass of the radioactive substance can never be less than 0.2 g. So m equals to 10e minus 0.01t plus 0.2. Okay, as t tends to infinity, 10e minus 0.01t, we know this tends to 0. Therefore, m tends to 0.2. M cannot be less than 0.2. Okay. We have a polynomial, and it has this factor and leaves this remainder. So we use factor and remainder theorem. So if we sub in 2x minus 1, so we use half. So 2 half cube minus 3a half square minus 2a half plus b. We can simplify this a bit. So this happens to be quarter minus 3 over 4a, and then this is a itself, so this is 7 over 4a minus 7 over 4a, then plus b, this is 0, and we can also sub in x minus 1, so sub in x equals to 1, so 2 1 cubed minus 3a1 square minus 2a1 plus b, and this is just 2 minus 5a plus b equals to negative 8. Okay, so you can go ahead and solve for a and b the normal way. Give me a minute. Okay, so we'll subtract the two equations so that we get 2 minus 5a plus b minus, quarter minus 7 over 4a plus b equals to negative 8. In other words, 7 over 4 minus 27 over 4a equals to negative 8. So 7 minus 27a is negative 32. So 27a, oh wait, no, I did something wrong. Let's see. No, this is correct so far. Oh, I think it's the subtraction I did. This should be plus negative 5 plus 7 over 4, so that should be 13 over 4. Ah, okay. Sorry. Okay, so minus 13a equals to, so there's negative 32, subtract the 7, so there's negative 39. So therefore a equals to 3, and one can find the value of b to be, if you put in the 2 minus 15, negative 13, so b should be positive 5. Okay. Hence factorize the following polynomial. Okay, so 2x cubed minus 9x squared, I believe. And then what else? Yes. So minus 6x plus 5. Okay. So we are given that 2x minus 1 was a factor. So we can write the other quadratic factor in the form ax squared plus bx plus c. And we will compare the coefficients to solve this. So let's see what we get. So by observation, a is 1 and c is negative 5. Okay. Then we can compare coefficients of either x or x squared, or compare of x. We have minus 10 minus b equals to negative 6. Oh wait, I should probably not use a and b because we already defined a and b earlier, so I should probably use different letters. Let's try p, q, and r. Okay, so this is p, this is r, then this is q. Okay, so q is negative 4. So therefore, we want to solve the quadratic equation. Actually, we don't need to solve anything. We just need to factorize it, right? Yeah, factorize. So this is 2x minus 1, x squared minus 4x minus 5, and it just so happens this can be factorized further. So it's 2x minus 1. This can be factorized into x minus 5 and x plus 1. Yes. Okay, so that should be it. a circle C1 has a diameter AB. Okay, so midpoint of AB will be the center of the circle. So you have 6 plus 12 divided by 2 and minus 2 plus 6 divided by 2, which gives you 9 and 2. Is it? Yeah. Okay. So AM squared, so the length of AM squared will be the distance formula. So I will use 9 minus 6 squared plus 2 squared. And you don't need the square root because we're taking the square of this. So this is 3 squared plus 4 squared, so this is 25. So therefore, equation of C1 will be, the center is 9 and 2, so x minus 9 square plus y minus 2 square, and the square of the radius is 25. So that will be the number at the end as well. Show that the equation of the tangent at A is this. Okay. So gradient of AM. So tangent is always perpendicular to radius, so we find the gradient of AM first. So that will be y2 minus y1 divided by x2 minus x1. So this is 4/3. So therefore, gradient of tangent will be the negative reciprocal, negative 3 over 4. We write the equation of the tangent using y minus, we are using a, so y minus, so the a is the 6 negative 2, right? So y plus 2, we use y minus y1 equals to m x minus x1. Okay, and then of course we expand this, so 4y plus 8 equals to negative 3x plus 18. Then we simplify, 4y plus 3x equals to 10. Yeah, that's what they wanted. Okay, cool. Another circle has center at A and its area is 1 over 9 that of C1. Okay, so when you scale the area down by 1 over 9, you're actually scaling the length by 1 over 3 because square root of 1 over 9 is 1 over 3. So you use your EMF property. The radius is 5 here. The radius will become 5 over 3. So the square is 25 over 9. So it's actually just the center will just be the coordinates of A, and the square, the radius is 25 over 9. So immediately you can actually write down the area. So you have x minus 6 square plus y plus 2 square equals to 25 over 9. That's it. Okay, the function y equals to 1 minus 0.5 cosine bx. Okay. State the amplitude. Okay, so that will be the coefficient of the cosine, but you always take the absolute value. So we put it as half, not negative half. It is given that the period of y is 2 pi over 3. Find the value of b. So remember, as b increases, the period decreases. It's an inverse proportion, and the standard cosine x has a period of 2 pi. Therefore, in this case, b must be equals to 3. And using our answer in part B, sketch the graph. Okay, so we're going to sketch the following graph, 1 minus 0.5 cosine bx. So you'll notice that it will actually never cut the x-axis, so that's a quite important factor. So let's see what that looks like. So this is x and this is y. Okay, so the equilibrium position is 1, and this is half, and this is 3 half. So this is 3 over 2, 1, and 1 over 2. Okay, so it starts at, it will start at 1 over 2, and then it will increase, and then it will decrease. It will attain its maximum value at when the cosine is negative 1. So for cosine 3x to be negative 1, you need x equals to, I think, pi over 3. So let's see what happens. So this is, oops, maybe draw it a bit smaller. So this is going to be pi over 3, 2 pi over 3, and pi itself. So we start here, and it will attain its maximum value here. Okay, then it will come back down. Oops. something like that, and then it will go up again. Okay, so indicate all the maximum minimum points. I think I need to move this a bit bigger, a bit higher. So bring this back up. Try to get the inflection point to be in the center. Though I think they will close one eye if you don't get it exactly there. Okay, something like that. Okay, so indicate the stationary points, and this will be your y equals to 1 minus 0.5 cosine of 3x. Okay, so it will complete one cycle if your b is 1 for 2 pi. So 2 pi, you will complete 3 cycles if you have 3x. But here we only got the pi, so 1.5 cycles. Makes sense? Cool. Explain how the solutions of this equation can be obtained. So there's clearly going to be some sort of relationship. So y equals to 1 minus 0.5 cosine 3x. Okay. And pi cosine 3x, plus 3x equals to 0. What we're going to do is we're going to try and get the equation here. So what we'll do is minus 0.5 cosine 3x will be negative 3x divided by 2 pi. So therefore we add 1 to both sides. 1 minus 0.5 cosine 3x equals to 1 minus 3 over 2 pi x. Is it? Yeah, seems to be. Oh wait. Negative 0.5 here. We need this to be positive, I think. Because if I bring the negative over, then I divide by pi, then I need to multiply by negative again. So yes, it will be positive. So this will actually be 1 plus. Okay. So so you can see that the solutions will be x coordinates of intersection oops, maybe I'll write this a bit clearer. Of intersection of line y equals to 1 plus 3 over 2 pi x with the curve y equals to 1 minus 0.5 cosine 3x. Okay, so if you equate the two together, you can try to get back the equation that you started with, and you should get it. So give me one moment. Yep. Question 9, solve the following trigo equation. Okay. Now you see cosine 2x and sine square 2x. Now we want to keep everything in terms of 2x. You'll actually notice that, remember, sine square plus cosine square is always equals to 1. So I shall write the following equation as 3 cosine 2x equals to 2 minus 2 cosine square 2x. And then I will add, I'll bring the left side over. So I'll get 2 cosine square 2x plus 3 cosine 2x minus 2 equals to 0. And one can, of course, make the substitution. Let u equals to cosine 2x, and you'll get 2u squared minus or plus 3u minus 2 equals to 0. Is this factorable? I believe it would be. 2u and then u. Yes, it is factorable, so this is minus 1 and this is plus 2 equals to 0. So therefore u equals to half, or u equals to negative 2. We will change it back to cosine 2x. Cosine 2x equals to half, or cosine x, 2x rather. Either it's that half, or cosine 2x is negative 2, which of course you know has no solution. So we just need to consider cosine 2x is half. So therefore, basic angle is cosine inverse of half is pi over 3. Oh wait, we're solving in degrees. Okay, basic angle is 60 degrees. So x is therefore 60 degrees over 2. Oops, so I'll write 2x first actually. 2x is 60 degrees, 180 degrees minus 60 degrees. Oh wait, no. Where is cosine positive? Cosine is positive in first and fourth quadrants, so let's do 360 degrees minus 60 degrees. Now 0 to 360 for 2x, for x means 0 to 720 for 2x, so we can keep going. 420 degrees. Oh no, I skipped. That's just 360 degrees plus 60 degrees, and finally 720 degrees minus 60 degrees. And one, you can deduce the possible values of x from here, which is 30 degrees, 150 degrees, 210 degrees, and 330 degrees. Okay, so there are 4 possible values. Given that y is x over 3x minus 4, find dy dx. Okay, so quotient rule. Denominator is 3x minus 4 squared. So keep the denominator first. Differentiate the numerator, you get 1. Now subtract x, and the derivative of the denominator is 3. So you get 3x minus 4 minus 3x. So you just get negative 4 over 3x minus 4 squared. Hence show that y is a decreasing function. So for this, we have 3x minus 4 squared is greater than 0 for all x except for, of course, 4 over 3. Therefore, negative 4 over 3x minus 4 square is less than 0. Therefore, y is decreasing. I should probably write dy dx here, just to be very clear. Okay, the dy dx has to be negative. That's why y is a decreasing function. Okay. In this diagram, okay, trigger real world context. So length of the spring is given by this equation. The shortest length of the spring, okay, so the minimum value of sine 4t minus pi over 2 equals to negative 1. At this point, L is 20 plus 3 times minus 1 equals to 17 cm. Okay. Always remember that the maximum and minimum values of the standard sine and cosine are 1 and negative 1. Find the time when the spring first reaches 22. So basically, we're going to solve the equation 20 plus 3 sine 4t minus pi over 2 equals to 22. Now, there's an identity. When you take sine x minus pi over 2, that's actually negative cosine. So I will write 20 minus 3 cosine 4t equals to 22. And of course, one can simplify this a bit. If I bring the 20 over, we'll get cosine 4t equals to negative 2 over 3. And then one can solve basic angle is cosine inverse of 2 over 3, of course. So this is 4t. but this is negative, so I want the second quadrant because that will be the first one. So therefore, T will be, it will actually be pi minus cosine inverse 2 over 3 divided by 4. And of course, you can find the, evaluate this. Oops, I think I'm on the wrong, oh, I'm on degree mode. So you will get 0.575 to 3SF. Okay. The diagram shows the semicircle diameter PQ. Okay, a bunch of information. Okay, find the perpendicular distance from R to PQ. So this is so area of triangle PQR is of course half times base times height. So half 6/8 equals to 24. Perpendicular distance from R to PQ is area of triangle. Is 2 times the area triangle PQR divided by the PQ itself. PQ is the diameter, so by Pythagoras, this is square root of 6 squared plus 8 squared, which is 10 exactly, so this is 24 over 5. Okay, so 24 over 5 cm. It is given that SV is x cm, show that this rectangle of area STUV. Okay, so it's probably similar triangles. Yeah, it's similar triangles. So we know the perpendicular distance is 24 over 5. Let me just illustrate that. Okay, so what now? Yeah, it's definitely similar triangles. Where does the tan x come into play? I can do... Oh wait, I can find perhaps the length of... Perhaps I can find the... This is 24 point... Oh no, I can find this PV in terms of x because of the similar triangles. 8 divided by 24 over 5 is the same as PV divided by x. And from here I can find... This is a bit tough. No, I should probably consider VU and PQ. Ah, okay. I can find PV and VR. Okay, so let's find PV. By similar triangles, PV divided by x equals to 8 divided by 24 over 5. Which is 5 over 3. So therefore PV equals to 5 over 3 times x, and VQ or VR? VR. Okay. VR is 8 minus 5 over 3x. Okay. Now that we have VR, we can use similar triangles again. VR divided by VU is PR divided by PQ. Okay. So that is by similar triangles, VR divided by VU, VR divided by VU equals to 4 over 5. So therefore VU will be 10 minus 25 over 12x. And then the area will be, just multiply this by x. Okay, nice. Okay, A equals to VU, never mind. I'm not consistent with using the magnitude of VU anyway. And I don't think the Cambridge notation requires us to write it that way. VU times VS, okay? Then you just multiply by x. There might be a shorter way to do it that I'm not seeing, but it's okay. Calculate the value of x for which a is a stationary value. So stationary means we differentiate. The a dx is 10 minus 25 over 6x. So to have a stationary value, we let dA dx be 0 as per usual. And we will find that x is actually we'll find that x is actually 12 over 5. Okay. Although you could have actually noticed that this is a quadratic, and completing the square will also tell you that 12 over 5 will give you the stationary value. Okay. A function is defined for all real values of x by this, such that the second derivative is 4e negative 2x. Okay, green is 3 when x is 0, passes through 2e negative 4. So f of f prime x will be the integral of f double prime x dx, which is minus 2e negative 2x plus c1 when x equals to 0, f prime x equals to minus 2 plus c1 equals to positive 3, so c1 equals to 5. So therefore, we can now find f of x by integrating f prime x dx. So we get e power negative 2x plus 5x plus c2. Then when x equals to 2, I think it's f of x is e to the power of negative 4. So in other words, actually, how about I write it this way? I add the thing first, 10 minus c2 equals e negative 4. So of course, one has to set c2 to be equals to 10. So therefore, f of x, plus rather. Okay, so negative, okay. And yeah, that's settled. F of x is e to the power of negative 2x plus 5x minus 10. Find the coordinates of the stationary point. So we let f prime x be 0. And we know f prime x is 5 minus 2e negative 2x equals to 0. And this can be solved in traditional ways. So this is 2 equals to 5. 5 over 2. Okay. So x equals to negative half ln 5 over 2. which is 0 point, or negative rather, 0 point, negative 0 point, I can't draw it. It's negative 0.45814 to 5SF, and we can find the value of y, or 45815, sorry. Okay, y will be equals to, well, we can plug it in back into here, so e minus 0.45815. Oops. Oh, give me a minute. Oh, okay, I just realized something. Okay, there you go. So y is negative 9.79. So therefore the coordinates of the stationary point is negative 0.459. No, 458, sorry. And negative 9.79. Okay. Determine the nature, we can consider f double prime. So that will be the negative 0.45815. So that is, well, it's going to be a positive number, I believe, in any case. Uh, 1.60 greater than 0. So therefore, this will be a minimum point, because the second derivative is greater than 0. Okay. Kinematics. V is t squared minus 60 plus 5. Find the distance at time t. Okay, so s equals to the integral of v dt, which is t cubed over 3 minus 3t squared plus 5t. Yeah, that's it. The c equals to 0, since when t equals to 0, v equals to 0, or s equals to 0 rather. T seconds after leaving the fixed point O implies that at t equals to 0, it is at the fixed point O, so the displacement is 0. Find the total distance traveled at the particle in the first 5 seconds. So for this, we need to be careful because the particle might turn. So v equals to, we can factorize it to t minus 1 and t minus 5. So particle changes direction at t equals to 1 and t equals to 5. In particular, t is moving forward at 0 t1 and backward at 1 t5. Okay, so the distance, if you need to make a visualization, you can draw the line. So you will see that s is here, so this is 0, this is 1, and this is 5. So what's going to happen is going to come here and it's going to come here. Okay, so you need to consider to add the displacement from 0 to 1 twice, and then subtract the displacement from 0 to the origin to 5, because I'll write S5 actually. Okay, S0 is 0. Okay, then this is S1, you need to consider the distance from the origin to S1 and back, plus the distance from the origin to S5. So this will be 2S1. S5 is going to be negative, so 2S1 minus S5. Okay, and then you can figure out what this distance is. So that will be 2 times 7 over 3. And what about the other one? Minus 25 over 3. So okay, 14 plus 25 is 39, so 13. Okay, so this is in meters. Okay, so this is the total distance, 30 meters. Given that C is a point at which the particle has zero acceleration, whether C is nearer to O or B. Okay, so A is dv dt, and V was t squared minus 6t plus 5, so this is 2t minus 6. When A equals to 0, t is 3. So S3, we find the displacement at S at t equals to 3. We'll get 9 minus negative 3, I think. Okay. Distance from here to B equals to negative 3 plus 25 over 3, and this is well, this is 14 over 3. No, wait, 16 over 3. Okay, so therefore closer to the origin, right? Because the distance to the origin is just 3, so it must be closer to O. Okay, yeah. So that will be it for the Methodist Girls paper. Overall, it's quite manageable, I think. Yeah, all the best for the A Math students taking the O-level paper on Wednesday afternoon. Hopefully I get the paper 2 out later this week before Friday for your O-level paper 2. Alright, take care.